With Archaeopteryx, feathers seem to have burst upon the scene fully formed, and biologists had to create theories about what primitive feathers might have looked like. They turned to the most amazing function of feathers, flight. They surmised that feathers evolved from reptilian scales, scales that grew long and thin, making them useful in flight.
One of the ideas about the origin of feathers was the classic notion that feathers are derived scales, modified scales. And therefore, for the people who envisioned this transition, they had to come up with a scale that was becoming longer and longer and longer in order to match the shape of a feather, and which sides were being frayed in order to also mimic the veined appearance and the appearance of barbs that feathers have.
For over a century, biologists had to create theories about what primitive feathers would have looked like. For most of the 20th century, the most popular theory about the evolution of feathers hypothesized that feathers evolved from elongate scales, and that these elongate scales evolved for some function in flight. Of course, that result was completely overturned with the discovery of Sinosauropteryx.
Sinosauropteryx was a small dinosaur who lived here in what is now Liaoning, China, 120 million years ago. Killed by a cloud of poisonous volcanic gas, its body was one of thousands entombed in the ashfall and preserved in astounding detail in the rock. In 1997, it gave scientists their first glimpse of primitive feathers, and they looked nothing like elongate scales, spelling trouble for this theory. It is an experience paleontologist Phil Curry will never forget.
The specimen was brought on the table in front of me, and it was in one of these beautiful Chinese silk boxes. When the box lid was lifted up and I looked at the specimen for the first time, within a millisecond, my eyes had been drawn to these feather-like structures on the outside of the body. I knew that, hey, this is something real, and this specimen is unbelievably exciting.
Preserved as a black halo around the skeleton is what appears to be a fine, downy covering of primitive feathers. Feathers on a theropod dinosaur. If this dino fuzz was indeed primitive feathers, then their origin would have occurred early in the history of these dinosaurs.
We could see that along the bottom of the tail of one of the specimens were very, very thick stalks, and that coming out of those thick stalks were many, many very fine fibers. And if you had to make an analogy, it would be with down feathers, because that's exactly what they looked like. We also knew from one of the other specimens that there were these feather-like structures that had been broken in cross-section, and when you looked at that, they were hollow, and they looked very much like the stalk on a feather too. So I think the strongest evidence we have right now is that what we see in Sinosauropteryx is a simple down-like structure, very similar in appearance, in having a central stalk and a very simple branching structure coming off of it.
But these fuzzy structures weren't flight feathers. What could they possibly have been used for?
The feathers, or the feather-like structures on Sinosauropteryx, are there simply as insulation, and they're there to keep a warm-blooded animal warm. In a way, I had always known that we should expect to find feathers on a dinosaur, because there were so many characters that birds and dinosaurs shared that the majority of paleontologists had already accepted the idea that birds were the direct descendants of dinosaurs, and in fact that birds were, in a sense, dinosaurs. And Liaoning provided that answer. We always hope for these things, but whether you expect to see it in your lifetime is another matter, of course, and I hadn't expected to see it in my lifetime. And yet I was one of the very first people to be privileged enough to look at a specimen of one of these feathered dinosaurs, and it was really exciting, I'll tell you.
But if the downy coat on Sinosauropteryx was made of primitive feathers, they certainly bore no resemblance to scales, elongate or not. After 100 years with no evidence to support it, the elongate scale theory had reached the end of the line. So, if feathers didn't come from elongate scales, where did they come from? Hoping to answer that question, Rick decided to look into the growth of feathers, and there he found an oddly shaped key, opening the door to their past.
The most fundamental consequence of how feathers grow is the realization that feathers are totally tubular. Really, most of the details about feather biology, their structure and function, can be understood as consequences of the fact that feathers grow as tubes of skin.
Rick hypothesized that the development of modern feathers mirrored their evolutionary history, and he looked to the growth of an individual feather for clues.